Hi everyone, I just wanted to make a quick video about part two of the mini project. So I've received a couple of questions from students, particularly in the last three parts of the problem, so E, F, and G. I thought I'd just make a quick video just summarizing what I'm looking for by using an example protein. So in part A, it's asking you to search for any SARS-CoV-2, so that's the name of the virus, or COVID-19, which is the disease caused by the virus. I found that searching by either of those names in the search bar will turn up multiple results for different protein structures from the virus. There's no quote unquote right answer to this. You can pick any protein that you would like as long as it comes from the virus. The second part in part B says what is its name and the PDB code for the protein. So the protein I'm looking at, for an example, is going to be CFD1. This is one of the proteins I worked on in grad school. It has nothing to do with viruses, but I thought I would use it as an example protein. So I've already looked it up, and now I'm looking for the name and the PDB code. So technically the name of the protein is CFD1, but the structure name is going to be FES assembly CFD1. So if you give me the structure name or the protein name, both are fine. Um, well, we didn't go deep enough into the subject to really learn individual names for proteins. So as long as you have the structure title, I'll be fine. And then it also asks for the PDB code. And you'll always find that right above the structure name. It's going to be a 4-character name made from numbers and letters. So in this case, it's going to 6G, 2G is the unique code given to this structure. Then part C asks what method was used to determine the protein structure. So if we just go down to the second portion of the screen where it says the method is X-ray diffraction. You don't need any more than that. Common methods of getting protein structures is X-ray diffraction, NMR. I think those are probably the two major ways of getting protein structures that you'll find in the PDB for COVID-19. But write down whatever it says under the methods section. Then it's asking in part D to take 3 screenshots from the 3D viewer. So I'll go to the 3D viewer. I had some students have issues with getting the 3D viewer to work. It was fixed, at least in their case, by just shutting down Firefox and then reopening it. I've tried it on both Firefox and Safari. Both 3D viewers worked for me. If it still doesn't work after shutting down your browser and opening it again, I'd recommend try updating your browser. If you still have issues with the 3D viewer, then email me and let me know. So all I'm asking you to do is just play with the structure to get more of a sense of what proteins look like, rather than when most people think of just like a slab of meat. So that's why I'm asking for just 3 different screenshots from different angles of the protein complex or the protein that you're looking at. And then part E says, does the protein you looked up have a quaternary structure? And so people were asking me, how do I tell if it has a quaternary structure? So for us, the way we're going to look at that is just when we do it, we're going to eyeball it, right? So most of the time, it's standard now to color each subunit a different color, just like you see here for CFD1. So one subunit is green, the other is orange. Occasionally, you'll see colors repeated. If that's the case, right, you're looking for individual units, and you're just going to count those up. As we get into parts E, F, and G, I'm really looking for your best effort because I can easily see people, getting a little confused or maybe, missing something slightly. That'll be entirely fine, right? We're brand new to this. So as long as I'm seeing really good effort, you'll be in good shape. Even if you don't quite hit the nail on the head, I'll be happy with that. So I would say that CFD1 does have a quaternary structure and it has 2 subunits. Some of the proteins you look at will just be monomers, and then they don't have quaternary structure and it stops at tertiary, so there is no subunits. Then part F asks how many beta sheets and alpha helices are in the tertiary structure of the protein. And it also mentions that if you do have a quaternary structure, just do this question for 1 subunit. So the way I originally designed this was that you just kind of move the protein in space and then try to count up to the best of your ability the different number of secondary structural elements. So if I'm looking at alpha helices, I see like 1, 2, 3, 4, 5 in the back, 6, 7. Right? You move it around a little bit, see if you missed anything. I think I missed 8. I would say that's a good approximation. Maybe there's 8, maybe there's 9. Like I'm saying, we're doing our best in visualizing here, right? And the same thing you could do with beta sheets. And beta sheets are going to be these things that look like arrows. So you can go through with that. I realize there's an easier way to do this. So one way you could do this is to go to sequence. If we scroll down a little bit, you'll see in the sequence chain view, and we can tell when it says chain, it's talking about one chain of amino acids, so one subunit. So that's why we don't have to worry about tertiary structure here. But we can see secondary structural elements. We have beta sheets that are represented by yellow arrows, and we could count those up. We also have alpha helices that have like this salmony pinkish color of these squiggly lines. So we just go through and we can count up beta sheets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would say that makes sense, right? There's other secondary structural elements we didn't really talk about. There were, a beta bridge. I'm not worried about that. I'm just looking for, let's just look at beta strands, and then don't worry about distinguishing between a 310 helix and an alpha helix. We'll treat them the same. They are structurally slightly different, but that's getting way beyond this course. I'm just looking for alpha and beta sheets. Then part G says to copy and paste the primary structure of the protein, and then how many amino acids are there. So there's multiple ways you could do that, right? We could take a picture of the screen. You could go to maybe even to another website and find it. Easier ways to do it, and I kind of left this up. This is intentionally vague, so you'd play around with things, right? You might recognize, oh, sequence might have my sequence, right? And then we can see we have downloadable files. A FASTA file, that's just a common way that biologists, it's actually part of a programming language, I think, or at least a way that you type out these sequence so that other programming languages understand it. But if you download that file, all it contains is going to be the amino acid primary structure, and it will be numbered for you, right? You could also do view sequence and image, right? And you have options to download. So you just go through, even if you did it off this screen, you can see there's 301, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 310 amino acids. All right, so I think that answers everything. So hopefully that was helpful. Just a reminder that it is due at 5 p.m. on Wednesday, which is tonight, at least the day that I'm recording it. All right, good luck.